term? What would be the 1000th term? We don't want to list all those out to do that. And we're also going to talk about infinite sequences. An infinite sequence is one that never stops and one that keeps going forever. And we're going to talk about how do you add up an infinite sequence. You can actually. It's impressive. We can.
How is that the font? No, actually. If it goes on forever, how can you add up something?
I'll show you.
No, I don't like the
You really can. Okay, so here's the first part of your homework today. It says, find the first 6 terms and the 100th term of the sequence a sub k in which a sub k equals 5k minus 3. The big thing is just getting used to the notation. K is just the term. So if I want to find the first term, I write it like this, a sub 1. And all you do is plug 1 in for k. So I would get 5 times 1 minus 3. 5 minus 3 is 2. They want you to find the first 6 terms. So they want you to plug in 1 through 6 and just see the pattern. And hopefully, pretty quickly, you'll see the pattern and you won't even be doing the arithmetic every time. But if I wanted to find the second term, I would say a sub 2. And that would be 5 times 2 minus 3. Or 10 minus 3, which is 7. Right? Follow me so far here? A sub 3 is 5 times 3 minus 3, or 15 minus 3, which is 12. You can always just keep plugging the numbers in, but also when you're going in order, if I'm going 2 and then 7 and then 12, could you get the next number without actually plugging it in? Because you're just adding 5 each time. You follow me on that? But just showing you that you can actually just plug it in every time. You get 5 times 4 minus 3, 20 minus 3, 17.
Oh, we got to find the first. I thought it was the minus 6.
5 times 5 minus 3, or what would that be, 22? And a sub 6 would be 5 times 6 minus 3, or 30 minus 3, which is 27. Find the first 6 terms of that sequence. It also says find the 100th term. The nice thing about having an equation is you don't have to go to the 100th term like Logan was trying to do because he thought this one just said find the 6th term. To find the 100th term, all you got to do is do what? Plug in 100 for k. So the 100th term would be 5 times 100 minus 3, or 500 minus 3 would be 497. Tomorrow we're going to get into more specifics of breaking up what type of sequence it is. Today there's going to be different ones. Like some of them are going to be like this, which are very linear equations, and some of them are going to be like this. But it's the same idea. Find the first 6 terms. This would be negative 2 to the first power, which would just be negative 2. Again, watch your calculators doing this. I recommend not even using a calculator, but with negative 2 squared, if you just type that in my calculators, I know it's going to tell you the answer is negative 4, but you should know that negative 2 squared is positive 4. So either use parentheses or just use your brain. Negative 2 to the third is negative 8. Notice a pattern here right away. I see it's negative, positive, negative. So that's something to notice as you're doing these. Negative 2 to the fourth would be 16. If I ask you to describe this pattern, you should see that we're just multiplying by negative 2 every time. A to the fifth, or negative 2 to the fifth, would be negative 32. And negative 2 to the sixth would be positive 64. What happens on this one when you do this in your calculator? The 100th term. Does it work out? Does it give you an answer? Like it gives you in scientific notation because it's such a big number. When you try to find the 100th term of this, you get -2 to the 100th power, which is a very big number. I'm okay with you writing it in scientific notation because otherwise you would need like 30, not completely 30 because you have all those numbers. But just give it to me approximately 1.27 times 10 to the 30th power. That's just rounding there, but that's a really big number. Questions about that? It's a little vocab word for you here. We call these explicit formulas, meaning that you can find any term that you want by just plugging it in. Not all formulas are like that, which is where the next page goes, but if they give you the equation, you can find any term very easily. As opposed to the next page, something called a recursively defined sequence or a recursive sequence. A recursive sequence is one that you need the one before it before you can find the next term. And so it says one in which you need to be given one or more of the first few terms. And I gave you an example. There's a famous example called the Fibonacci sequence. And it's a pattern that looks like this. And people get very worried about a formula like this because there's lots of letters and they get really worried about it. But basically, they give you the first two terms. Notice they start with a sub 0, so that's kind of interesting. But they give you the first two terms of the sequence. It's 1 and 1. And then to find the next term, they give you this weird looking formula. But basically, if this is a sub 0, this is a sub 1, the next one in line would be a sub 2. So notice I'm plugging in 2 for k. What's going to happen here if I plug in 2 for k? I'll just show my work here. I would get a to the 2 minus 2 plus a to the 2 minus 1. You with me on that? I'm just plugging in 2 for k. And I'm going to simplify this. 2 minus 2 would be a sub 0 plus a sub 1. So here's what a recursive sequence does. It uses the one before it, or in the Fibonacci sequence case, it uses the 2 before it. To find the next term, you have to add up the 2 before it. So I have to take a sub 0 plus a1, or I get 2. We could keep writing it out like this, but what would the next term be if I just was looking at this pattern and I know the next number is the sum of the two numbers before it? All right, I'll write it out. To find the next one, just going in order, a sub 0, a sub 1, a sub 2. A sub 3 is the sum of the 2 before it. So that's going to be the sum of a sub 1 plus a sub 2. Where am I getting these numbers? 3 minus 2 is 1. 3 minus 1 is 2. Do we know what these two numbers are in the sequence? 1 and 2. And what is 1 plus 2? 3. What's the next term going to be? 5. You just take the 2 before it and you add it up. And then the next term, 3 plus 5 is 8. 8 plus 5 is 13. Right? You don't have to write out the formula every time. You can. But the idea with the recursive sequence is you need one before it. If I asked you to find the 100th term on this one, is there a shortcut way to this, or you got to go all the way to the 100th term? Yeah, I don't really know that I got a shortcut for you right now. So you'll notice they don't ask you for the 100th term on these. Fibonacci sequence is a special one. The ones in your book aren't usually this complicated. They usually just use one before it. So let's look at another. Like this. Notice this one says write the first 4 terms and the 8th term. And the 8th term for this sequence. Again, notice how it's written. Instead of saying a sub k equals, it says a sub k plus 1. So if this is a sub 1, we already know that the first term is 15. Right? Every recursive sequence will give you at least the first number. And then what are we going to do to find the next one? We're going to use this sequence. And it just says to find the next one, you're going to take the one before it and add 3. That's just what that notation means. So if I want to find a sub 2, I'm going to take the one before it, which would be a sub 1, and I'm going to add 3 to it. Or, do you agree that's just saying 15 plus 3, which is 18. So notice this out here. They say for k greater than or equal to 1, that means you can't start with 1 because they already gave us 1. Right? So they're always going to say that out here. If they give you the first term, they're going to say k has to be greater than or equal to 1 because you already have the first term. To find the third term, I'm going to take the one before it, which is 18, and I'm going to add 3 to it, and I'm going to get 21. Well, I don't know. Can we find a shortcut to get us there without having to add it every time? I agree that these are the first 4 terms, 15, 18, 21, 24. It's saying to use this formula, you have to choose bigger than 1, is what it's saying. Like, this has to be, they give you this. You can't use this formula for the first term because they gave you the first term, is what that's saying. But that does count as your first term. Sorry if I wasn't clear about that. Logan's saying, why don't we just go to the 8th term because we need the 8th term anyway. It's not that hard to go to the 8th term by just adding. It would be a pain to go to the 100th term. Could we get to the 8th term without actually finding everyone? What are we doing every time to these numbers? Adding 3. So let's see if we can think about this. Going to the 8th term, how many more times am I going to need to add 3? A to the 4th, so to a to the 5th I would add 3, and then a to the 6th I would add 3, and then a to the 7th I would add 3, and then a to the 8th I would add 3. So could I take 24 and add 3 4 times? Does that make sense? Or add 12? That's about the shortest thing I have for you, Logan. Is it that much effort to actually just keep adding 3? No, it's not. But I think that you could do that. Do you agree with that? You get 36? That would be the 8th term without actually having to write out every one. People get thrown off by these recursive ones, but just remember, you're just using the one before it, so don't get too worried about it. We'll get one more, and then we'll probably just have to do the converging and diverging tomorrow. Yeah, and here's a great way to know if it's recursive. Anytime they give you the first number, right? Or anytime you see a formula with a +1 or a -1, that means that it's a recursive sequence. And it's the same direction as number 3. We want to list the first 4 terms, and we want to get the 8th term. Again, notice it's written like the last one, b sub k plus 1, 3 times b sub k. That just means 3 times the one before it. And again, they're telling you, you have to use this formula starting with 2. Why? Because they give you the first term. The first one's free. B sub 1 equals 2. So you're going to start using that formula for greater than or equal to 1, which means you're going to start with b sub 2. And all you're going to do is use the one before it. So 3 times b sub k, I'm going to take 3 times the one before it, or 3 times 2, which is 6. For the next one, I'm going to take 3 times the one before it, which is 6. Yeah, that's just saying the next one in line. So like, you start with k is greater than or equal to 1. So when you plug 1 in here, 1 plus 1 where I get the b sub 2. You plug 2 in there, 2 plus 1 is just the third term. You don't do anything with it.
I know
It's just,
that. I'm talking about the preview.
right?
Okay, has nothing to do with
That just means the one before it. So if this is b sub 3, right? If the one before it would be b sub 2, it's always just the one before it. Is that 54? We could just keep going all the way out to the 8th term, or you could kind of just do it on your calculator and skip down to b sub 8. You do have to do a little bit more work than on the explicit one, because you have to figure out what I'm going to multiply each time. But I don't feel a need to write it out every time. But I am going to take 54 times 3. That would get me the 5th term. Times 3 again would give me the 6th term, the 7th term, and the 8th term. And what did you end up with for the 8th term? Did anyone get an answer? 4,374. And so that's kind of my little work in between without listing everyone out. How do you feel about that? I think we're going to stop there, which means you're going to have less homework today, but then the rest of this homework is going to be added on to tomorrow's homework, because we're finishing this section up tomorrow. So let's look at the homework assignment so that I can adjust which ones you can do today. You're welcome to look ahead at the converging and diverging. That's the only thing we didn't get to today, but we'll finish that up tomorrow. And we definitely can do 1 through 4. And then I think you're just going to be able to go to 6 through 10 right now. Yeah. So 1 through 4 all, 6 through 10 even. And then we'll do those other 5 problems, 12, 14, 16, 18, and 20. We'll add those on to tomorrow's. But today it's just explicit terms and recursively defined terms, which aren't so bad to do. So make sure you bring these notes back with you tomorrow, because we'll finish using them. And I might even print your notes out for tomorrow. Let me pause this real quick.